We've now arrived at a topic that most finance professors probably view as the most important topic that we're going to cover in this entire course, and that's the time value of money. To sort of lead into this, let's talk about the capital outlay decision. The capital outlay decision, in this context, we're basically asking whether or not the future benefits that we're going to derive from some project justify the current outlays. So, are the future benefits worth the current outlays? In order to make that decision, we're going to need some mathematical tools, and those mathematical tools are time value of money tools. In this case, we also want to recognize that capital outlay and capital budgeting, when we hear the term capital budgeting, we're really talking about this process. Choosing projects, which projects are we going to provide capital to? Which projects are we going to fund? The essence of this chapter is time value of money, and really that's a discussion of the mathematical tools that we're going to use to address this type of decision. We're going to start out very simple. We're going to start out with the future value concept for a single amount, meaning a single dollar amount today. We're going to find the future value of that dollar amount. So this is measuring the value in the future of an amount that's allowed to grow at a given interest rate over some period of time. First example, calculate the value of $1,000 after it earns interest for 4 years at 10% interest per year. Well, we're going to build this fairly slowly. What's the value? Well, after the first year, that $1,000 has grown to $1,100. So we have $1,000 in interest plus, $1,000 in the initial principal amount plus $100 of interest. In the equation that you see here, the interest amount is that 10%. The principal amount is that 1. So this could be rewritten as the term that I have circled, 1 plus the interest rate. That doesn't look very nice, but essentially that's what we have here, 1 plus the interest rate. In the second year, we take that $1,100. It's going to grow by 10% for another year. After 2 years, it's going to grow to $1,210. Now, notice a couple of things. One, it's grown by 10%, but it went up by $110 this year. In the second year, the value only went up by $100 in the first year. What happened? Well, what happened was we earned interest not only on the $1,000, but we earned interest on last year's interest. This is referred to as compounding, earning interest on interest. So compounding causes the value to grow more rapidly over time because we earn interest on interest. After the third year, this has grown to $1,331. We take the $1,210 from last year. That's the beginning number this year. It grows at a 10% rate again. We've grown to $1,331. In the fourth year, again, we take third year ending amount, invest it for a year, grows at 10%, $1,464. Now, we could rewrite all that. So we've gone mechanically through the process. We could rewrite all that. Essentially what we've done is we've taken $1,000, invested it for a year, and earned 1 plus I times 1,000. We took that amount, this full amount, invested it for another year, earning 1 plus I. Okay, we did that every year for 4 years, 1, 2, 3, 4. The other way we could write that is 1,000 times 1 plus I raised to the fourth power. And that's how we're typically going to write this from this point forward. So rewriting what we had there, just to sort of clean up the previous slide, make it look a little less crowded. We see each of the 4 years independently growing by this interest amount, but we can sum it all up as a single equation here at the end, which is 1,000 times 1 plus I. In this case, I was 10%, which we show like this: 1,000 times 1 plus I raised to the fourth. 1.1 raised to the fourth is 1.464. So 1,000 times 1.464 was $1,464. We can use a generalized formula, which is what we see right here. Now, this is one of the most important formulas that you're going to see in finance. The future value is equal to the present value times 1 plus I raised to the n. So in our case, our present value was $1,000. Our 1 plus I was 1.10. N was 4. And the whole thing, it came to $1,464. So that's the application of that formula. So future values, FV is the future value, PV is the present value, I is the interest rate, and N is the number of periods. From time to time, we find it convenient to use a table to solve this kind of problem, and this table is listed as Table 1, Chapter 9, I believe it's Table 9-1 in the textbook. Recall that our future value formula relies on future value equaling 1 plus, or the present value, times 1 plus I to the n. Well, this table is the future value of a single dollar. So up there at the top, $1, that's the present value we're dealing with. This table, because we only have two other variables left, we have I and we have n. Once we know I and n, we know what the value of this whole expression is. And that's all that we're doing in this table. So the future value of $1 raised that earns 10% a year for 4 years, we just run across the table. We find the future value is equal to 1.464. That's the future value of a single dollar after 4 years. If we wanted $1,000 after 4 years, well, all we have to do is take the value that we have in the table and multiply it by 1,000. In other words, the 1,000 is this guy right here. We have found the value of this table, in this table, assuming $1 in the future. However many dollars that we're interested in, the present value we're interested in, we're just going to multiply by the value in this table. So in our case, 1,000 times 1 plus I raised to the n power, where I is 10%, n is 4, gives us $1,464. The expression that is on the screen right now, future value equals present value times, we refer to this as the future value interest factor, meaning this is just the value from the table, from the future value table. That's what this little IF means, interest factor. So the future value is equal to the present value, 1,000, times the future value interest factor, which was the number that was pulled from the table. So $1,000 invested for 10 years at 8%, the future value would be, well, we take the present value of $10,000, the future value interest factor for n equals 10 and I equals 8, we pull from the table is 2.159. Let's go back and look at that. I equals 8%. Number of periods is 10%. The future value interest factor for those two is 2.159. So that's what we've got right here. N equals 10%, I equals 8%. Pulling it from that future value table, we come to a value of, from the table, 2.159, which we multiply then by the $10,000. So $10,000 invested for 10 years at 8% interest. The future value is $21,590.